Today we are going to talk about average value. This is a very big topic on the AP. So this is definitely one we want to be able to know. And it's a very easy topic as well. We've actually covered it quite a few times in the past week or so. So we're going to start off with kind of an easy problem. Imagine we are riding a bicycle, and the velocity of the bike at certain times is shown on the table below. So we're going for about basically 9 seconds. Now the question that we're being asked is to determine the average velocity of the bike over the course of 9 seconds. Then they do tell us just use the left Riemann sum. We'll talk about that in just a minute. But I want to talk about the phrase average velocity. Now we know from physics and earlier math courses that if I want to find velocity, I have to get the change in distance, and I divide that by our change in time. Now, this is going to give me my units. Well, distance over time, in this case right here, we're talking about meters and seconds. We should get meters per second. So let's talk about our velocity, our change in distance over our change in time. Well, what's going to give us the distance? Well, we're given velocity, but how do we get distance? Well, we covered that before. If I'm given position, velocity, and acceleration, if I got position and I want to get velocity, I know I have to take a derivative. But if I'm given velocity and I want to find position, I go in the opposite direction. We're looking at an antiderivative right here. So if I want to get my distance I traveled, I have to take the antiderivative of my velocity. So that's what I'm going to do. I integrate my velocity from 0 to 9 v of t dt. Remember, velocity times time. Look at this. This is velocity times time. That's going to give me my distance. And I divide that by the amount of time, the change in time. Well, I'm going for 9 seconds, so that would be like 9 minus 0. Now I have to do the hard part. I have to get the distance that we traveled. Well, since they didn't give me a formula, I have to look at this as an area problem. So when I want to find the distance, v of t dt, I have to use my Riemann sums. And of course, Riemann says they tell me here to do rectangles. So I'm going to go ahead and do that. Use my Riemann sums, 0, 2, 5, and 9. Well, between 0 and 2, we're going to use the left. They're saying use 10. Between 2 and 5, using the left, I'm going to use the 15. And then between 5 and 9, we're going to use the 17 value. And I can get this area by looking at the area of these rectangles. That's what they're asking me to do. The first one is 10 by 2. The next one is 15 by 3. Notice the sides are different. Plus 17 by 4. And if we evaluate this, we're going to get 133. Now the units, we already know that the antiderivative here is going to be my distance. This is going to be something meters, so we traveled 133 meters. So I take that 133 meters, and I divide that by the 9 seconds that we traveled. And that's going to give us a whopping 14.778 meters per second. Now, this is a lot of work. Now, even though this is side work, it's not scratch work. This work right here is needed. It is just as important as all of this right here. So, how do we get average value? Well, it's simple. First things first. So this is my average value. Now this is just, we first solved it up here just by kind of thinking about it. How I want velocity, so what do I need? Distance over time. Well, how do I get distance? That's just where my integral comes from. We talked about that earlier this year. So the mathematical way now, it's also easy. The first thing we want to do is we want to find the area under the curve. So if I graph this parabola from 0 to 2, I graph this parabola, negative x squared plus 4, there's 4. I want to find this area. Well, problem is, there's no formula for it. I know what you're thinking, can't we just use a circle? Well, we could if it was a circle, but it's not, so we can't use that. So we have to integrate this from 0 to 2, negative x squared plus 4 dx. And if I evaluate this integral, we get negative x cubed over 3 plus 4x, and we evaluate that from 0 to 2, just our FTC. F of 2 minus f of 0. Well, if I plug 2 in, I am going to get, be careful, 2 cubed is 8. I get negative 8 thirds plus 12. Plug in the 0, that's nice. And negative 8 thirds plus 12 is going to be 16 thirds. This is my area. So the first thing we do to get average value is we have to find the area of the curve. Remember, when I'm looking for average value, we're looking for the average y value of our function. And we're going to treat this like it's kind of like a derivative right here. We're going to find the average value of this. So we're going to find basically its function. We'll see about that in a second. That'll make sense in a second, hopefully. Next, after you get the area, we're going to create a rectangle on the same domain that has the same area. From 0 to 2, I am going to create a rectangle here that has the exact same area. Now, this has a change of base of 2. Next, we ask ourselves, what would be the height of this rectangle? Well, we know that area is the length times the width. So therefore, if my area is 16 over thirds, if this is my width times 2, I therefore know my length has to be 16 over 6. So the height here, the height of that rectangle is 16 over 6. This is the average height of the function on the domain 0 to 2. Of the function on the domain 0 to 2. So this is my average height, or y value. The height of the rectangle is what we call the average value of the function. In other words, if I were to look at that function again between 0 and 2, I know that the area here is 16 over 3. The height, the 16 over 6, is my average value. In other words, to get the area, I could take that 16 over 6, multiply that by 2, and we would get 16 thirds, which is the area of our function. And we do this all the time with grades. If your grade in class is like at 85, that means that is like the average of all of your grades in the class. Right there. This is sometimes called the mean value theorem of integrals. And this is basically what it says right here. The mean value theorem for integrals, or the average value formula theorem. If f is continuous, then there exists a number on C such AB such that if I were to multiply the function by our domain, if I were to multiply the value of that function by our domain, we're going to get the area of the function. So if I can take my average value, multiply that by our change in our domain, we're going to get the area under the function, or that the area of our rectangle is the area of the function. And that's a big one. The area of this rectangle is going to be equal to the area underneath that function. In other words, there is an x value on AB where we can build a rectangle whose area equals the exact area under the function itself. So go to part 2. We're going to take a look at a few more examples here.